Hi, I'm Harrison, the DevOps software AI engineer here with eTop Web Technologies, and I'm here with my colleagues.
Hello, I'm Koye, a front-end development engineer here at eTop Web Tech.
Hi, I'm Usani, a front-end development engineer at eTop Web Tech.
Hi, my name is Gideon Usani, and I'm a front-end web development engineer here at eTop.
Thank you. So today, we want to show you guys how to weave together high-performance, high-level guide in architecting, designing, building, testing, and deploying applications. Again, this is a high level, so we want to show you how things are done. So, what we'll be building? We'll be building an e-commerce website. So this is the landing page of the e-commerce website. So we have the listing page. As you can see, we have the features as well. And we have a single product details page and checking out the cart page as well. All right, now we have phases of web application. So web application here could mean desktop, mobile, or even a web services. And there are 5 phases that you as an engineer would definitely take when building any variant of an application. So here we have, first would be you architect the application, design the application, build, test, and deploying this application. So these are 5 concrete steps. So we'll take this step one at a time, and Michael. So now the question is, who is an architect? In order for you to quickly recognize what an architect would do is that, first is that it boils down to 2 components. So which is functional and non-functional requirement. So basically an architect designed the overall structure of the application. Again, an application here could be a web, desktop, mobile, or even a backend service. And also to ensure it meets both functional and non-functional requirements. So what is functional requirement? So functional requirements specify what the system should do. So in this case, an architect will define the specific behavior or function of the system. So take for an example here is within our eTop shop, an architect will define the product management, the user registration and authentication, shopping cart and checkout process. So we're going to keep the momentum going by considering one at a time. An example of a functional requirement here is the product management. So in our eTop shop must allow administrator to add, to update and delete product within the catalog. So example is provided here, so which is administrator can upload a new product with a name, description, and price and image. User registration. So in this shop, an architect will, of course, this is an example of functional requirement. It will allow users can register with an email and password and receive a confirmation email to activate their account. Example of a functional requirement, which is shopping cart. So in this eTop shop, must allow user to add product to shopping cart and manage the item in the shopping cart. So as you can see here, user can add item to their cart, remove item, and adjust quantities. Checkout process, which is again another example of a functional requirement. In this eTop shop, the eTop shop must provide a checkout process where users can enter shopping information, choose a payment method, and place an order. So now, the second part is the non-functional requirement, which an architect will define. So yeah, non-functional requirement define how the system performs. performs a particular function. So they are often referred to as quality attributes of the system. So an example here is the performance, scalability, security, and usability. We can also have maintainability as well. So performance. In here, a top shop must ensure that the product catalog page loads within 3 seconds under normal load condition. So take for an example, the product catalog page should load within 3 seconds, even with up to 100 or 10,000 concurrent users. Scalability, which is again an example of a non-functional requirement. In here, the system should be able to support up to 10,000 users simultaneously without significant performance degradation. Security, which is very, very, very important in a web application or in any services you're building. Take for example, in this a top shop must protect user data through secure authentication methods and encryption. An example here is user password must be stored using strong encryption, and the system should support multi-factor authentication. Usability, an example of a which is an example of a non-functional requirement here is that a top shop must provide an intuitive and easy to use interface for both users and administrators. If we want to dig down further with an example, so the user interface should be clean and simple, with clear navigation and accessible control for managing the shopping cart and checkout process. To sum everything, or in order for us to weave everything together, it is now safe for us to define an architect based on this ETOP shop as an architect designed the overall structure of the ETOP shop, in this case, an e-commerce platform, ensuring it meets both functional requirements, such as allowing an administrator to add products and user to complete the checkout process. And non-functional requirements include fast page load times, scalability for increased traffic, secure user data protection, and an intuitive user interface. So now, to keep the momentum going, what will an architect do in our ETOP shop? First, an architect will define the system architecture. So take for example, create a high-level architect diagram that includes the front end, the back end, and database layers. So as well as how they connect and communicate. So this is a diagram. So as you can see, we have the front end, which in this case, which is the client, consists of HTML, CSS, and React, and we have the server side as well, which consists of the backend, and the backend communicate with the database. So in this case, we're using this is an example of Node.js. You can use Go, Java, and the database here we're using MongoDB. So this could be MySQL, Postgres as well. What will an architect do in our ETOP shop here? An architect will choose appropriate technologies. So take for example, decide to use either React for the front end, for its components-based architecture, and Node.js for the back end, or even Go or Python or Rust. An architect will choose technology. So in this case, the back end could potentially be Node.js and Express, MongoDB, and GraphQL. So front-end could be React, Redux for state management, Nest.js, and probably Webpack. An architect will create a high-level diagram and documentation. So it's part of what an architect will do in our ETOP workshop. So take for an example, producing a detailed system architecture diagram that illustrates the flow of the data between the front end and back end, and the integration point with third-party services like payment gateways and shipping APIs. So we have a very intuitive diagram here. As you can see, we have the user interface, the front-end application, which again is communicating with the backend. The backend here is talking with the database, shipping API, and payment gateway. So all these could be their different services. And as you can see, the shipping API is communicating with a third-party shipping provider. That's why we have the front end, which of course, consists of static content delivery for caching, and we also have a CDN as well. Yeah. So let's keep going. So that completes the overall phase of the architecting the application. So again, to keep the momentum going, I'll be moving to the designing phase. So the question is, who is a designer? A designer creates the virtual layout and the user experience of the application. So in this case, what a designer would do in our top shop, a designer would create a wireframe and markups. So a designer, they might use Figma as an example, using Figma to create a wireframe of the top shop homepage, including the section for the headers, product listing, and footer. So this is an example of what a designer would create. So that completes the first and the second phase of when you're building a web application. So it's now safe to pass it to my colleague Koye.
Thank you, Mr. Harrison. So we're in the third phase of the application development now, which is the building phase. So we start with the developer who will be building the actual application. So who is a developer? So a developer writes the code that we'll use to build the application based on the design and the architectures that have been given in the earlier phases. So the software can run on the web, just like a website, on your phone as a mobile app, on a computer as a desktop application, and on servers or in devices like your smart fridges and your smart TVs. So now we'll talk about what the developer will do in our ETOP shop. So when developing a web app, we have the front end and we have the back end. I'll be talking to you about the front end. So the front end is what the users see and interact with. So the buttons you see, the text, the images, the layouts that you see on your web browser, that is the front end. So we have three core technologies for the web. So we have the HTML, the CSS, and the JavaScript. Then on the other side of the coin, we have the backend. The backend works behind the scenes. So it handles data, security, logic, and storage. So let's talk about HTML now. So HTML is an acronym and it stands for Hypertext Markup Language, which is the standard markup language we use for documents that we want to display on a web browser. So the way HTML works is basically the skeleton of the web page. So it defines what is on the page. Like I said earlier, the text, the images, the buttons, the links are all specified from the HTML. So HTML does not control the way these things look. It only controls what's there. So let me show you an example of what an HTML document looks like. Here we can see our HTML documents. So instead of going deeper into it, I'll just give you a high level explanation so you get an understanding of how HTML works. So we have the head. In the head, we can link. The head is basically like the brain of the HTML. So we have the metadata, the titles, and linking to other files that we might access in our HTML documents. Then in the body, we have the visual part of our HTML. So here you can see we have a header which contains the ETOP shop logo, the search bar, and other information. So this is how a HTML file looks without CSS. As you can see, it is not styled. It is just a plain document, and this is not what we want our users to see. So that's what leads us to the next technology that we use in front-end development, which is CSS. So CSS stands for Cascading Style Sheets, and it's a style sheet language used for specifying the presentation and the styling of the documents, which we have written in a markup language. The markup language in this instance being HTML. So, like, this is pretty explanatory, but the way we talk about it is CSS is used to style the HTML. So we use it to make the HTML document look good. So with CSS, you can change a lot of what was specified in the documents, like the fonts, the colors, the layouts, the animations, and much more. So in this case, I'll equate the CSS to like clothing or makeup of a website. So it makes things look attractive and user-friendly. So this is an example of CSS code. So here we can see the tags, that the elements from the HTML which we are referencing and we are styling here. So basically the CSS is used to style what has been specified in the HTML. Then let's see our application now with HTML and CSS. You can see we have our text, our images have been styled, our font has been changed, we have added the layouts, and now our application looks like an actual website, not just a document. Then we also have the JavaScript. In the JavaScript aspect, we'll be talking more about it in the backend, but for the front end, the JavaScript is just used for interactivity. So instead of, because currently we just have plain documents, so we use the JavaScript for interactivity between components and also if we're interacting with the backend. So you can use JavaScript to respond to clicks, validate forms, load data from our API, and even build full applications with just JavaScript. So to come again, the three technologies we used was HTML, CSS, JavaScript. We use HTML for structure, we use CSS for styling, and we use JavaScript for interactivity or the logic. So now we'll be going on to the backend part of our application. So thank you.
All right. Thank you, Mr. Koye. We'll be walking you through how APIs and databases are being integrated into an application or a software application. All right. So before I move further, I would love to mention what APIs and databases are. So APIs are like a transportation network that moves information or transport information between two systems. This time around, between a backend and a front end. All right. Whereas a database is basically a store where information about an application or all information rendered on an application is being stored. All right. So when it comes to our e-stop shop, we need a way to show customers what products we have in stock or what products we have in our database, but we need to get that information from somewhere, which is our database in this case, and display it on the front end for our customers to see. All right, such that front end could be a React front end. So now let's quickly dive into how APIs are being implemented. In this case, we'll be taking an example using a RESTful API. That is implementing a RESTful API in Express.js to fetch products data from MongoDB and display it on the HTML or React front-end. All right, before I move further, let me quickly expatiate on what Express.js and MongoDBs are. They are basically, Express.js is basically a backend framework for building a backend functionalities, and a backend interacts with a database. In this case, MongoDB is a database. So our Express.js backend is going to interact with our MongoDB to get all the information we are being stored there about our product, and get it displayed on in a HTML front end or a React front end. All right. So into the next slide, I will show you how this is being wired up. I mean, how it is being implemented. An Express.js framework is being implemented. All right. So we can see this screenshot here showing how an Express.js backend is being implemented and how it interacts with the backend with a database. In this case, a MongoDB. All right. So after which we can see this Mongo client. This is basically where our backend is being connected with our database. After which we try to get all of the products that is being stored in our database, using these API routes. That is /API/products. That is an API route. So of course, our server or our backend is being run on a local host which has a port of 3000. And you can see this log saying that your server is running on port 3000. All right. So in the next slide, I will show you how these products can be presented or displayed on the UI. That is how our front end can interact with our Express.js backend. All right. So now you can see this. This is a React.js front end, and this is a component that fetches the data or gets the data from the backend. That is all the products from the backend, and then render these products on our UI for our users to see and interact with. So we use a use effect in React to do this because it's the hook that interacts with the outside world and external resources to get external resources from an external source. In this case, our external source is the Express.js backend. All right. So remember, I mentioned we are going to be using that API/product routes to get all our products from the backend. All right. So we have this fetch function, which is a native fetch functionality for getting for running a fetch request. All right. We're using it in the use effect, so to interact with the outside world. All right. And then we render the list of the product being gotten from the backend. So that is basically how to integrate the RESTful API into our front end, be it a React front end or a normal HTML or native HTML front end. So the next phase will be how to test and deploy an application, which you will be walked through by my colleague, Mr. Gideon. So Mr. Gideon, over to you. Thank you.
Thank you very much, Wilson. So after the architecture stage down to the designing stage and the development stage, one of the most crucial stages in developing an application is the testing phase. So in this phase, this is where we check for functional and non-functional components of the app that they are properly working. So who is a tester? A tester is a QA engineer, ensures that the application works as intended and is free of bugs. When we say a tester is checking if the application is working as intended, we can use an example of adding to cart. So when a user clicks the add to cart button, we are going to check if this is functional, if the front end is properly communicating with the back end, and in the case to explain the word a bug, in the case where this is not functioning properly, we do call that a bug, right? So what the tester would do in our ATOP shop, a tester is going to write and run a test case, right? An example of writing a test case is writing unit tests for React components and integration tests for API endpoints. So there are several tools that are being used when doing these tests. We have the Jest and we have the subset. Jest, a JavaScript testing framework used for unit and integrated testing, subtest, a library for testing HTTP and API endpoints. So moving on, the another thing a tester is going to do is perform manual and automated tests. So we have both manual and automated tests. Example, we can use a Selenium for automated browse testing and manual testing for checkout process. Okay, so the final phase for a tester is that after the test is done, we report and track the bugs. So example of a tool which we could use for this is using Jira to report bugs and track their resolution. So just to summarize everything the tester does, the tester primarily makes sure that the application is working properly, that everything is functioning as it's supposed to function. Thank you.
Take it again. Thank you, Gideon. So now the final stage is the deploying the web application or web services or mobile or desktop application. So who is a DevOps engineer? So a DevOps engineer manages the deployment and infrastructure of the application. So what a DevOps engineer will do in our GitHub shop first is that a DevOps engineer will set up a continuous integration and continuous delivery pipeline, or it could be continuous deployment pipeline. So one of the differences is that continuous delivery requires human intervention to approve the code, and continuous deployment does not require human intervention. So all the way from GitHub to the cloud. So take for example here, a DevOps engineer will of course use Jenkins or GitHub Action to automate the build and deployment process for a top shop. So basic example here is a DevOps engineer will configure Jenkins to pull code from the GitHub. So as soon as developer make changes and push those code to GitHub, Jenkins will pull the code, and of course we have to set up an automated test to run on each commit and deploy the application to AWS using AWS Elastic Beanstalk on successful build. The reason why we choose Elastic Beanstalk is the flexibility. So this is service provided by AWS that requires you as a developer to provide your source code to AWS, and AWS will take care of the infrastructure for you, the auto scale security as well. What a DevOps engineer would do in our GitHub shop here is that it will deploy the application to production. So in our case, a basic example here is that we use AWS Elastic Beanstalk for deployment to set up auto scaling to handle traffic spikes, and also to ensure backups and monitoring are in place. Monitoring and maintaining the application health, which is very, very important as well. So take for example, we use AWS CloudWatch to monitor performance metrics and set up alerts for any issues. So an alert here could be set up to either Slack or to notify the developer via email. In here, you can see that we can, of course, configure AWS CloudWatch to monitor the CPU and memory and network usage. Like what I said previously, we can set up alerts for high error rate or performance downgradation. Of course, regularly is very important. Regularly, we review logs and metrics to identify and address an issue proactively. And That concludes the deployment phase. And with this, I believe you have a high level understanding on how to architect, design, build, test, and deploy an application. So in addition to set up the infrastructure, deploying the application, we can as well apply several deployment strategy like canary testing. So this is outside the scope of this tutorial. Thank you very much and see you in our next video. Thanks.